All right, in this video, we're going to focus on the other three types of transformations that can be performed on a function. Those would be stretches, compressions, and reflections, okay? And there's actually two types of stretches and compressions, both in the vertical direction and in the horizontal direction, okay? Um, so the vertical stretch or compression is going to take place in the scenario where your function f of x is being multiplied by a value of a outside of the function. So a times f of x, okay? And depending on the value of a, that's going to determine what type of vertical effect you have, whether it be a stretch or a compression. So let's go back to the Desmos activity, and I'm going to bring box 6 into play here. So notice box 6 is a times f of x, and right now I have the slider for a set at 1. So think 1 times f of x is the original parent function, right? So that's why the blue graph looks like our original parent function, okay? So if I change the value of a, let's make a larger than 1, notice what happens to the blue curve. Okay, so it appears, I guess I would describe this as kind of like a steepening effect, okay? But really the technical term here, this is a vertical stretch that's taking place, okay? Each one of the y coordinates from the original parent function, they're being multiplied by whatever the value of a is. So they're being pulled in the vertical direction or stretched in the vertical direction, okay? So I like to imagine it, it's like if I were to take the black curve and grab it from the top and just pull upward, I'm stretching it vertically, right? Okay. So that takes place whenever a is larger than 1. But notice right here, I bring a back to 1. When I start to make a smaller than 1, it has like a flattening effect. And this would be called a vertical compression. Think of it like taking the black curve and pressing it down from the top. You're compressing it to give it this flattening effect. And what's happening here is all of your y coordinates from your original parent function, they're being multiplied by that value of a. And since that value of a is smaller than 1, it's decreasing in value. The y coordinates are decreasing in value. Okay? All right, so we formalize this. In the case of a times f of x, when the absolute value of a, now notice I didn't take into account any negatives for a. That's because whether it's positive or negative doesn't matter in terms of a stretch or a compression. We'll see what the negatives do here later. So in terms of a stretch or compression, I just need to look at the absolute value of a. As long as it's greater than 1, that means f of x will be vertically stretched by a factor of a. Okay. Now, when I say by a factor of a, factor implies multiplication. So that means that the y coordinates are being multiplied by a from your parent function. Okay. Now, in the case of the absolute value of a being between 0 and 1, we just saw we would be vertically compressed by a factor of a as well. Okay. All right, so look at our example. We have 0.5 times f of x. Notice it's the same parent function I've been working with. And in this case, f of x, since it's being multiplied by a number that's smaller than 1, we're going to get a vertical compression. Parent function will be vertically compressed by a factor of 0.5. Okay. And it's again our y coordinates that are being affected here. So to go from f of x to 0.5 times f of x, you're just going to take all of your original y coordinates and cut them in half. Negative 2, 4 will become negative 2, 2. Negative 1, 1 will become negative 1, 1 half. 0, 0 is going to actually stay put. 1, 1 will become 1, 1 half. 2, 4 will become 2, 2. So we plot each one of those. And here we now have 0.5 times f of x. All right, so again, think of it, the original black curve there, you're just smashing it down from the top. You're compressing it downward so it has this flattening effect. Okay. All right, now we move on to horizontal stretches and compressions. And these are ones you really got to be careful on because just like the horizontal translations, things occur opposite of what you would expect based on what the function's equation looks like. Okay, so let's go back here. I'm going to go to box 8 now. And the horizontal stretcher compression takes place when you're multiplying x within the function. So notice in box 8 I have f of b times x. So the b is multiplying x within the function. And right now b is set at 1, so I have the same graph as the parent function. Okay. Now, if I make b larger than 1, notice what the graph does. Okay. It appears to be like a steepening effect. It looks like it's having a vertical stretch taking place, but actually what's happening here, we're going to describe this as a horizontal compression. Okay, it's not the y coordinates that are being affected here, it's our x coordinates. And what's happening is the x coordinates are being they're being made smaller here. They're actually being divided by the value of b. Okay, and just think of it. It's like if you were to take the black curve from the left and the right side, and you were to try and smash it together, like sandwich it together, it would have a steepening appearance or a steepening effect to the curve. Okay. Now, if you make b smaller than 1, now notice it kind of has this flattening effect, but we're going to describe that as a horizontal stretch. So now it's your x coordinates, they're being increased from the parent function. And think of it, it's like you're taking the black curve from the right side and you're pulling it in the positive direction to the right. So it's going to have that a flattening effect, but we're going to call it a horizontal stretch. Okay, these are really tough to get your head around. Okay, all right. So in the case of f of b of x, where b is greater than 1, its absolute value is greater than 1. We've seen that you're going to have a horizontal effect. It's actually going to be a horizontal compression. So f of x will be horizontally compressed by a factor of 1 over b. So even though x is being multiplied by b, we're actually going to multiply all of our x coordinates by the opposite, 1 over b. Okay, and then f of x will be horizontally stretched by a factor of 1 over b, as long as the absolute value of b is between 0 and 1. Okay, all right, so here our example is f of 0.5x. So obviously b is 0.5 here, and that means 1 over b would be 2. Okay, so our parent function is going to be horizontally stretched in this case. by a factor of 2. Okay? Notice again, even though we have 0.5 within the function, our factor to stretch here is actually by the opposite of that, which is 2. Okay, so that means all of our x coordinates are getting doubled from the original parent function. So negative 2, 4 is going to become negative 4, 4. Negative 1, 1 will become negative 2, 1. 0, 0 is going to stay put. 1, 1 is going to become 2, 1. 2, 4 is going to become 4, 4. Okay, go ahead and plot all those. And again, I know it has kind of like this like widening effect here. Think of it, it's you're taking both ends of the original parabola and you're pulling them to the left and to the right to have this stretched appearance. Okay. All right, last type of transformation we need to look at are reflections. Okay, reflections occur whenever you are using a negative value inside or outside your function. Okay, so let's come back here one more time, and I want you to notice right now I just have the parent function in black shown. Let's say I change f of x to being the negative of f of x. It just reflects it across the x-axis. That's because the y-coordinates are changing sign in the case of negative f of x. Now, if I have f of negative x, where the negative is inside the function, now the reflection is across the the y-axis. That's because it's the x-coordinates that are changing sign in the case of f of negative x. Okay. So we just saw that negative f of x will reflect f of x across the x-axis. It's the y-coordinates from your parent function that are being multiplied by negative 1 in that case. And then f of negative x will reflect f of x across the y-axis. And that's because it's the x-coordinates that are being multiplied by negative 1 from your parent function. Okay? All right, so now we have negative f of x we're asked to graph here. That will give us a reflection across the x-axis, and all of our y-coordinates would be changing sign from the original points. So negative 2, 4 becomes negative 2, negative 4. Then we'll have negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 4. Go ahead and plot them. And here we go. So that's negative of f of x. All right, now it's your turn. Here we've got very similar practice problems to the previous video. You are going to be describing the type of transformation that's going to take place on f of x, and also what operations will occur on the coordinates of each point. And notice I have made it so that some of these functions have a couple different transformations taking place. Okay, so pause the video, try to work through these on your own, and then come back, check your work with mine. And in the case of f of 2x, the 2 is inside the function, so that's going to have a horizontal effect. We will have a horizontal compression in this case. Okay. And it would be by a factor of 1/2. So that means your x coordinates are being multiplied by 1/2, and your y coordinates are not going to change. Okay. 3 times f of x plus 2. Two transformations taking place here. So let's focus on the plus 2 first. That's happening inside the function. So this is going to be a horizontal translation, 2 units in the negative direction. Remember, it's the opposite here, so to the left. And then the 3, it's multiplying outside of the function. That's going to have a vertical stretch effect. Vertical stretch by a factor of 3. All right, so your x coordinates, they're just going to be subtracted by 2. And your y coordinates are going to be multiplied by 3. Okay. All right, last one here. Again, 2 transformations taking place on the negative of f of x subtracted by 2. Notice both the negative and the subtraction by 2 are happening outside of the function. Okay, so those are both going to have an effect on your y coordinates. X coordinates are not going to be affected at all here. So I'm going to put an NA right away. The negative 2 is going to have a vertical translation effect. Okay, vertically translated down 2 units. And then the negative that's multiplying f of x is going to give you a reflection across the x-axis. Okay, so that means you're going to multiply your y coordinates by negative 1, and then you're going to subtract by 2. Notice you got to follow order of operations there. You want to multiply first and then subtract.